how we're doing it, I'm kind of thinking about two different things. Like, is this skill a mastery skill or is it a survey skill? Is this something that's good for you to see, or is it something I actually expect you to be able to do now and then later? So like taking derivatives of things, that's a mastery skill. We need to be able to do that now, and we need to continue to be able to do that. A lot of these very difficult conceptual questions at the end of the homework, these are survey skills. It's just giving me an opportunity to talk about these ideas that might be important later on, but I wouldn't expect us to necessarily remember it just as like a jumping off point for like building a connection that maybe we use in the future. The other the other thing, along with what Jacob was saying, with the min and max problems, is there's probably two different ways to do that problem, right? One way I could give you a equation. The other way we could give you a graph is probably the presentation you get. So again, that's a question that could be presented as a function, as a table, as a graph, and you should be able to kind of do that regardless of how that function is provided. And you might even see two separate questions based on that, where certainly one of them is much easier with a calculator and one of them is much easier with, or still very doable without a calculator, depending on the presentation. If all you have is a graph, well, that's fine. I can still do everything I need to do with that without a calculator, right? So that's, those, I think those are all great examples of stuff. The other big topic here that we saw in this group of questions that you guys haven't mentioned, like the mean value theorem stuff. So I would expect that you're able to find the C's, the values of X, such that the mean value theorem holds, right? The mean value theorem says for a continuous differentiable function f of x, there exists some C on the closed interval a to b such that the derivative at that C is equal to the average rate of change for the function, f of b minus f of a over b minus a. Should be able to find those values of C. It just turns into like a solving for X problem, basically. But the setup involves some calculus. And you have to be careful about the conditions there, that you have continuous and differentiable, right? But should be able to do that as well. But I think you'll find that the questions here in this that you're going to be asked to do are all very similar feeling. Like, like finding the maximums and minimums is basically the same as finding your intervals of concavity, same as finding your inflection points, same as finding a critical value. It's kind of all the same process. It's just like, am I using F? Am I using F prime? Am I using F double prime? And it's kind of all saying the same thing. Okay. Does that help at all in terms of like focusing? Yes. Okay. So let's go for the what if questions, and we'll do some specifics. Okay. Pierce.
Will there be like a question if you use like the first or second derivative rule, you'll say use one over the other?
I will not direct you to use one or the other. Now, you may run into a problem where you have to use one or the other because of what you're given. And I think my classic example, if you looked at the MCQs, I think it was like number 80. Yeah, where the derivative is given as an implicit function where you have x's and y's on the same side. It's impossible to use a first derivative test on this because there's no way to figure out what are their x, y's lie on f because you don't know what f, you don't have an equation for f. So you'd have to use a second derivative test on this. But I would not tell you that you must do, you use whichever one you like. As long as it's as long as it's possible to use in any context. Beck.
For the one regular question, do you think that would fall into the same concepts as the FRQs, or is there something specific
Well,
we should look at?
what haven't we talked about that we spent some time in class doing? L'Hopital. Does that feel like a regular question to me? Sure does, right? Like, there's no way to make that a multi-part question and just like do some limits, right?
Would it be more like the really chunky ones?
Really chunky ones.
Like 83 was pretty chunky.
Oh, no, I don't think I would ask you to do something that's that complicated on there. Let's take a look at what we're talking about.
Or is anything that doesn't involve ETS or the natural law?
83, 71. No, those are beyond the scope of what I would probably ask you. I think something like, that chunk of stuff from like 7 to 66, I think are all pretty fair. That are just like, here's no words, just like do this limit. And I would probably tend more towards the stuff like between like up to 48. After 48, some of them start getting kind of nasty. Still, I think fair, but like if I'm being mindful of time, I have to be realistic about like what can we do. Does that help?
Yes.
I think it just comes.
Thank you.
Yeah.
And this is 3.9 to 4.4.
Correct.
So that's not that much.
It's 3.9 is hard, and then 4.1, 4.2, 4.3 are all kind of the same thing. Like they're all related together enough to where it's like this is just kind of one topic to me.
Let's see, 4.4 was great.
And then 4.4 is just like a standalone also, like kind of unrelated to either of those two. So it's kind of like three topics, right? It's like, can I do a related rate? Can I do this min-max, concave up, concave down, increasing, decreasing stuff? And then can I do L'Hopital? Is that basically what the test boils down to?
Okay.
Jacob.
Wait, so I was a little off. So the regular question is like a question that's not multiple choice.
Well, and it's not multi-part. It's just like, do this problem.
It's like the questions that we had.
Like a homework problem.
Okay.
Where it's not like, I'm asking you to do a million things and like you're building on one answer or one response or like it's some complicated situation. It's just like, do this. You know what I mean?
Yeah, then the rest is multiple choice.
So the multiple choice or multiple choice free response have multi-parts, right? Okay. So let's just homework. You could use the MCQs, sure. If you did them, you can use them. Yes, you have to have.
Like my.
Yeah.
What about the FRQ?
We've talked about those. If you did it, sure.
If I do it, I can have. Oh,
Sure.
yes.
Yeah. Yeah, why not? Right?
And then hypothetically, could we go through and label the multiple choices based on their unit, kind of?
Yeah, whatever notes you want to write on it is if it's part of like something you did by yourself
Yeah.
and it's part of like you doing the homework, I'm not going to complain about that. I would caution you guys about not like overwhelming yourself with homework stuff. Like you coming in with like 50 pages of homework is probably not going to be helpful in finishing on time because you're going to spend 15%, 20% of your time like flipping through looking for what you're looking for. You might be better off being like, I'm going to have, like 2 or 3 good things, that I'm picking out of these, different areas and just kind of saying I'm going to pick, like these 6 homework problems and these 6 homework problems and these 6 homework problems and just kind of label them and just study the rest so that if it's like something that I'm confident I can do, I don't want to bring a bunch of that stuff that I'm going to have to sift through to find the stuff that I know that I'm going to struggle with. I would probably be a little bit choosy about what I'm bringing, because I don't want like an encyclopedia to have to look through, right?
Yeah.
Yes.
It's not about this test, but if we're gonna retake a test, does that have to be done by December 8th?
I don't think that counts, since you wouldn't necessarily be doing it in class, right? It'd be done in a testing room or a study hall. So I think that's okay. But we need to do it before the exam so I can have an accurate grade for you going into the exam and stuff. Yes, Isabel.
Are you gonna ask us any questions that would require us to like know the answer? I still don't know. Yeah.
I'm gonna be honest, it's fair. It's a fair question for me to ask. Now, this unit circle business, no, it's not part of it's not a homework problem.
What is right? What if there's a homework problem that requires me to know it, so I sketch it?
Here's let's just think about this reasonably, okay? Because you guys you're all very smart, right? The unit circle values listed from biggest to smallest are these ones. That's it. Those are the only 5 points, coordinates that appear on the unit circle anywhere, right? So if I say, what is, sine of pi over 3? So what I'm thinking in my head is pi over 3 is the big angle. So here I have small x, big Y, right? So this should be 1/2 and root 3 over 2. That's all I'm thinking about, right? So sine of that should be the big one. Pi over 4 is here, pi over 6 is here, 0's here, and pi over 2 is there. But that's all I'm thinking about is like, if I draw the coordinate, is x big or is x small? And I'm just filling it in. Or are they the same? Right? Like,
If you know those, would it just like flip?
yeah,
On the rest of them?
yeah. You just need one quadrant.
So then what is it? Then it
Well, this is like x is
Oh, then x is just
x is negative and y is positive.
negative.
Yeah, it's the same as the first
But it's gonna be
quadrant.
the same no matter what.
Yeah,
Okay. That actually
Right?
like a revelation.
like that's all I don't memorize it. I just like, is the x or y the big or the small one? And I'm just doing that.
This makes a lot of sense.
Well, it's because we didn't require you to memorize it last year, so why bother spending a bunch of time talking about how to memorize stuff?
Took away our district circle.
Okay. Well, that's the way I think about
It
it.
was traumatizing.
That's the way I think about it.
Wow, it actually makes so much sense.
Yeah, no one's ever explained it.
So, sure. I'm glad I could help.
All students take.
Yeah. Sine is positive because the y is positive there,
Take tan positive.
because both are negative.
This cos positive.
Yep. Because the x is positive. Yeah.
That's what it was. We did it last year. It was like all students take calculus, and it was like for everything. It was all for
So this stands for which trig function is positive in that quadrant. A is all of sine, cosine, and tangent are positive. S is sine is positive, so cosine and tangent would be negative. C is cosine, it goes like that. Sure. All right. Should we go move on to questions?
Yes.
Yes.
So many.
Okay, let's do as many as we can. Of course. Elena, go ahead.
I don't even know where to start.
If you are ready, let's go. Just whatever you find right you're looking at. Doesn't have to be at the start. Tell me the section.
So 4-4.
Okay.
Can I just give you like 193 and
Sure.
41, 49, and 55 is what's done.
Okay, let's do 41.
Wait, what is it? Is it one?
That's the one I'm gonna pick.
We like broke.
I
would have
think
to
we
print
did like
20,000
500.
pages to
Yeah,
get
we
through
did
all.
like like
You got a goal to reach, buddy.
Every single student.
Thank you.
Okay,
Oh, that looks scary.
so we want to start by doing our direct substitution.
How do you that's confused with substitution.
So I plug infinity in for x, well that's infinity.
Oh, that's it.
And then what do I get when I plug infinity in for sine of pi over x? I get sine of pi over infinity, right? What's pi over infinity though?
0.
And what's sine of 0? 0. Right? Remember, sine is y. 0 is just on the x-axis, so y is 0 there, right? So that's one of our indeterminate forms. That tells me that I should be using L'Hopital's rule to do this. However, the way it's currently written, I cannot apply L'Hopital's rule because it's not a fraction. So I either need to write this as x over 1 over sine pi over x, or write it as sine of pi over x over 1 over x.
It has to be a fraction.
Correct.
Oh.
Look, for L'Hopital to apply, the indeterminate form has to be 0 over 0 or infinity over infinity. So this one, I think the natural choice would be to do sine of pi over x over 1 over x. Although I think that's going to end up being a bad choice, and I'll talk about why in just a second. But I'd expect that this would be what we would want to try. And instead of writing that as 1 over x in the denominator, I'm just going to write x to the negative 1. Well, I just wrote x as 1 over x.
Oh.
And then I just multiplied the fraction, right?
Yes. Okay.
And then I just wrote 1 over x instead. I just wrote it as like x to the negative 1 down there because it's like way nicer looking.
Yes.
And then it's obvious to do the power rule with that when I do my differentiation. So let's apply the L'Hopital. I guess we should check for direct substitution here. You get 0 over 0. I should probably make mention of that. So the derivative of sine of pi over x is cosine of pi over x times pi x to the, negative pi x to the negative 2. And then over negative x to the negative 2. So I had to do the chain rule here. So I thought about this as pi times x to the negative 1. So I could, when I did my chain rule and did the derivative of the inside, it's now just a power rule derivative instead of a quotient. Because I'm going to avoid trying to do the quotient rule if I can. Right? If I can get away with doing a power rule instead, let's do that because the quotient rule is like yucky. Back.
Since pi is constant, you don't have to do product rule.
Correct. Because pi is a constant, I can just ignore it. I don't need a product rule on that. Very good. Yes. Okay. So if I now do my substitution, I get cosine of 0 times, when I plug infinity in here, that's infinity in the denominator, so that's going to be 0. And so that's, again, 0 over 0. That's not helping, right? So I can either try differentiating again, but I don't like where this is heading because what's going to keep happening here? It's just going to keep getting more and more negative, so it'll stay 0 in the denominator the whole way through. That feels like I'm not making any progress. So maybe let's try doing it the other way, which is what I kind of thought was going to happen, although I figured it's a good opportunity to talk about this. Yes, Tessa. No, go ahead. So if I have negative x over x squared, and I plug infinity in, I have 1 over a gigantic number, which is just going to 0. Is that okay? And again, if you have to write out more than I do, it's okay. Like, it's very natural for me to do this. I can do it very quickly. If it's not quick for you, say something. I can kind of re-explain and do a little bit more detail. And if it's on the test, go slow, right? Like, it's okay. Write out more than you need. If you have to like really write it out with everything plugged in and just, okay, yep, 0, 0, okay. And just check, right? Okay, so I would probably at that point have quit on that route. Well, oh, what if I put left the x as the numerator and did this? Now there's an opportunity here to make life a little bit easier. What can I do with that? Yeah, let's think about that really. It's just cosecant of pi over x. That probably makes life a little bit simpler because now I don't have a fraction inside of a fraction. Still doing okay? If I plug this in, I got infinity over infinity for direct substitution. Cosecant has an asymptote at where sine is 0, so at 0 there's a vertical asymptote. Everybody's okay? Okay. So let's L'Hopital this. What's the numerator become? 1, because we're just taking the derivative.
Oh, we're doing
Yep, because we're applying L'Hopital's rule, which is I'm excited about because now I know that I'm going to get, this is my answer. I just have to do the derivative of the bottom correctly because I don't have a 0 or infinity on top, so it's not going to be indeterminate. I have an answer. Okay. What's the derivative of cosecant?
root 1 minus x squared.
That's for cosecant inverse, I think is what you're talking about, which is not, and that's not quite correct. I think it's negative cosecant times cotangent. Am I right on that? Okay, if you're not, these were things that we need to memorize like forever, these derivative rules. So if you need to refresh yourself on some of these things, make sure you do that in advance of Friday, right? There's a Quizlet with all the derivative rules in it. Go back and run through that a couple more times and just sharpen yourself up a little bit.
Question, would you use the inverse deck versus, when do you use it?
Well, if it was like that, then you'd use the inverse derivative rule, right? If it was cosecant inverse that you're taking the derivative of, then you'd use the rule for cosecant inverse,
Oh.
right?
I gotcha.
Okay, so when I do my direct substitution, that's 1. And I have cosecant 0 times cotangent 0. Both of which are infinity. So that's just heading to 0, right? Now, in many cases, deciding which one you want to put in the denominator of a multiplication problem doesn't matter. In this case, it did, right? If I kept the first choice that we made, you could have L'Hopital that till the cows came home and I don't think you're going to end up with anything you really were very happy with. So usually if it's a situation where there's a choice and I can't see that my L'Hopital is making any progress, maybe I'm going to stop and try the other choice. Now, if I see that I'm making progress, like I've gone from like x cubed to x squared to x, it's like, okay, I'm making progress. I just got to keep going until I've cleared the x's out of there and it'll be fine. But on a case where you have trig stuff, that never really goes, you can't really differentiate out a trig thing, right? You can derivative out a polynomial, but you can't really get rid of a rational, you can't really get rid of a trig exponential, so you have to be a little bit careful about that. Beck?
So for cosecant of 0, it would be 1 over 0, right? So that's why it's infinity?
Yes.
Okay.
Isabel?
Just like, I just don't remember why we did like x over 1 over sine pi x. Like, what was the explanation for that?
To use L'Hopital's rule,
It has to be a fraction.
yeah, your indeterminate form has to be of the form 0 over 0 or infinity over infinity. So to start, you have to have like a f of x over g of x. And we didn't have that at the start. At the start, we had f of x times g of x, right? So the solution is, well, what if I just write f of x as 1 over f of x? That's still just f of x. And now when I do, then I have g of x over 1 over f of x. And now it's a L'Hopital form. Does that feel okay? Yes. And I think this is a nice, fair level test question. You had to only use L'Hopital one time to do it. Now there's the catch is that you had to be careful about how you wrote the fraction, right? Because one way was going to make progress, the other way wouldn't. But yes,
So the 2 different colors, was that 2 different?
approaches.
Oh,
Yeah, so we started off with the red one and we got to like what felt like a dead end. You know, like this looks like it's an endless, you know, where I'm not going to be making any progress. I'm just going to keep getting, you know, 0 over 0, 0 over 0, 0 over 0, and just like, what am I doing here? Like, I'm not making any headway.
yeah, just like, I guess I missed that.
No, it's okay. Yeah. Beck?
For the mean value theorem, FRQ,
Yeah.
should we prepare to have that be like one of the proving ones? Or
No.
or just a-
No proof. No proof. Like, prove this thing has at least 1 0 or whatever, you know. No. Don't worry about that. Yeah, don't worry about that. Good question, interesting question. Like, if you take college calculus, probably a question you'll get asked. Yeah. Here's the thing, like, if you are a collegiate professor and you're a practicing mathematician doing mathematics research, you are concerned solely with proof. You're concerned solely with proof. That is what gets published. And so, as a result, your philosophy is, I need to prepare my students to be able to do mathematics research. We have to be able to do these things. I'm going to ask you proof questions, and I'm going to expect that you can either do this or you can't. Now, if you're planning on engineering school and you have an engineering mathematics department, maybe that's a different, you know, a horse of a different color. I didn't have that undergraduate background, but I can assure you, like, that if you're going to a research university and you're having like a full professor as your mathematics instructor, proof is going to be part of the class. Okay? It'll be part of the class. As part of homework at minimum, and probably test as well. I don't want to scare you. I just want you to understand like where they're coming from and why all of a sudden you're seeing this. Okay? Isabel.
So this is an example that you didn't even know.
Sure.
And I was just like confused by it.
Okay.
It was also 4.4.
Okay.
And it's to find like law to find like limit as x approaches 0 from the right, and then x very last.
Yeah.
I was just like confused.
Okay. So what we did is I need to somehow write this so that I have a fraction somewhere, right? Now, anytime you have something that's in this indeterminate form of like 0 to the 0 or 1 to the infinity or infinity to the 0, where you have an exponential, the trick is we're going to do like e to the ln of the stuff. Now, what does doing e to the ln do? They cancel each other out. It's like doing nothing at all, right? But what it allows me to do, because I have the log there, is I can use like my properties of logarithms to move that exponent to a coefficient. And now this part is a multiplication problem. So I can write this as like that. And I now have a fraction. That's something I can L'Hopital. So if I have,
So we have to prove, like, we have to write all those steps if we see the exponential steps.
I would like to see that you did that. I think would be something I'd be looking for. I don't think I would give you something that requires this much manipulation to get into a L'Hopital form, but you certainly would see it if you're taking a college calculus course, and I think it would be not unreasonable if the AP had something like this. So what we can say here is that we can say that's going to be the same thing, right? Yes, Tessa. Well, here's what we can do. Remember your limit laws. E to the x is a continuous function, right? So I can push that limit into the exponent. And now I'm just doing that limit, which is exactly what I need to L'Hopital. I'm sorry, you said something very quietly and I missed. No, the e still hangs there, but it doesn't play out when I'm evaluating the limit. But I'm going to have e to the whatever my answer is here. So when I L'Hopital that, I think I get 0. So I end up with e to the 0. And that's one. I think that something with this much manipulation to get to the point where you can do a L'Hopital is more than I think on a single test that I would ask you to do. Although I would say in your college calculus course, I would say I'd expect to see something of this level of complexity. And I would say that even if the AP had something of this level of complexity, it wouldn't surprise me. Maybe let me rephrase. I would be surprised but not shocked, right? I'd be like, oh, that's a tough one. But it wouldn't be like, oh my God, I can't believe they did that. Okay, Beck.
Does it matter which direction the limit is coming from for these problems? 0 from the right.
So the reason, so Beck asked the question here. This problem, the limit is from the right. The reason that they did that is because the limit from the left of the natural log doesn't exist. So it just ensured that this, when we do our manipulations, that the L'Hopital can still be done. So there's just them thinking ahead. Elena.
Last night when I was doing my homework, I watched like a YouTube video that
Sure.
and it said that I can do like the natural log of y equals a, and that like y equals a.
Yeah, that's exactly what we just did.
That's what this is.
That's exactly what we just did there. Yeah.
Okay.
So so what they're saying here is they're saying, okay, like let y equals x to the x. So I do the natural log of y equals the natural log of x to the x, which is just x ln of x. So I'm going to do the limit of this thing and then plug that in, you know, like we'll get that answer and then we'll do e to the both sides, which cancels the, you know, out, the ln out. Now I have, you know, so I have like this, and then I have this, and then I do the limit here, and I do the limit there, and like it's the same thing. So it is just different work doing the exact same process, though.
Okay.
It should give you the exact same result.
Okay.
Does that feel okay?
Yes.
I've seen that done, like notated that way also.
Okay. Yeah.
I just always like, it boils down to doing like, if you have an exponential thing, you just do e to the ln of the stuff, and then use your log rules to manipulate, and then make a fraction out of it after, and then push your limit up into the exponential, and I don't know, it's like 6 of one, half dozen of the other to me.
Okay.
But it's doing the same thing.
Okay.
Is that
Yes.
okay? And I hand waved at this thing a little bit because you knew what I was talking about, and I didn't want to show
Yeah.
another method of doing the exact same thing
Yeah, no,
for everyone else. And like,
Because I had done that in one of my homework classes. I was just wondering if
it is okay. It's the same thing.
okay, good.
Tessa. Yeah, let's do it. 59 from 4-1. Okay, sure. If I tell you this is too much, you'll take me at my word though, right? If I'm like, oh, this is like more than I want you to worry about. That is a tiny little thing, huh? All right. Okay, that's fine. And it's asking for absolute mins and maxes for this, right? Okay. So, start with the derivative, yes? If we're looking for absolute or relative mins and maxes, it doesn't matter. So that's a product property, because I have x times an e to the whatever. So I'm going to have x times, and then what's the derivative of e to the negative x squared over 8? Well, the derivative of the outside is just the same thing. And then the derivative of the inside is going to be negative 2x over 8. Is okay? And then I'll have the derivative of x times the outside.
Why would you do
Because 8's a constant.
Oh.
You could. You'll get the same thing with a lot more work. But does that feel good? All right. So now I'm going to find my critical values by setting this equal to 0. To solve this equal to 0, I notice that, hey, each term has a e to the negative x squared over 8. So I'll just factor that out. And that gives me a negative x squared over 4 plus 1. You see the negative x squared over 4? X times negative 2x, and then divide by 8. At this point, I can apply the zero product property. Since that's a multiplication problem that's equal to 0, I can just set the factors equal to 0. Now, if I try to solve e to the negative x squared over 8 equal to 0, what's the solution to that? No solution. Very good. If you take the natural log of both sides, natural log of 0 is undefined. So we're done with that piece. Over here, I'm going to subtract 1 and then multiply by negative 4. And then we'll square root both sides. And I get plus or minus 2. Subtracted by 1 and then multiplied by negative 4.
Oh.
So my test values are, what was the interval again? Okay, so look at the interval though. We're going from negative 1 to 4. So I can't have -2. So the test values are -1, 2, and 4. So clearly that's my absolute minimum, since it's the only negative one. That's got to be the smallest. And then which one of these two is going to be bigger? Be careful about that. So that's 2 over e to the 4th, right? That's going to be smaller than 2 over e to the 1/2, right?
What?
So this should be my abs max. Ideally, you'd have a calculator to do this. I would suspect that this would be a calculator problem with the e's in it and the negative exponents. That's pretty rough to try to do with no calculator, but I can do it. If you thought about it long enough, you'd be able to do it. You just have to think about it in the right way. It's like, oh yeah, sure, e to the 4th on the denominator is a much bigger number than e to the 1/2. Okay, so 2 over e to the 4th is smaller than 2 over e to the 1/2. Rough, but like, oh, and that should have been 4 here also. Not that it matters. Right? But that's what I would do for that. Was the solving probably the tricky part? So almost any time you have a product property, there's going to be some nice factoring that you can do that'll get you into a form where you can do zero product property and go from there. And very often, if you have an exponential, you're going to get a no solution from the exponential part. Isabel. 4.423. Sure. You guys feeling any better as we're kind of talking through stuff and doing things and getting a better picture of kind of where my expectations lie here? Yeah? Nah? Maybe?
I feel better about knowing what I don't know.
Okay. That's something, right? All right. So, worth pointing out to you that L'Hopital's rule would not be necessary on this because we do have another method. You can multiply by the conjugate here, and it should work out for you pretty nicely. I'm not going to do that because, well, we're trying to get away from like a bunch of like single situation tricks and just have like L'Hopital as our big trick. It would be the same thing with just a plus sign in between. So just as a quick check, if I plug 0 in, I get 1 minus 1 over 0 from a direct substitution. That's L'Hopital. Now this is a chain rule problem. Now that chain rule was fine, whatever. The nice part is, though, that look at what the denominator's turned into. 1 tells me I'm done. If I did the calculus correctly, that was all the L'Hopitaling I need to do. If I direct substitute here, I have 1/2 times 1 plus 0 to the negative 1/2 times 2 minus 1/2 times 1 minus 0 to the negative 1/2 times negative 4 over 1. So what does that give me? It gives me 1 minus, plus 2 over 1. So it should be 3. Does that feel okay, Isabel?
Maybe I was just like overwhelmed, just like nervous about like experience, and I was like, I just don't even know how I should approach this, so I just skipped it.
Yeah. And you see now that, like, valid, right? Like, if you're working on homework and you get to, like, why I'm not going to spend 20 minutes grinding on one problem right now because I have other things to worry about also. But if it's in that indeterminate form of 0 over 0 or infinity over infinity, just we're L'Hopitaling, and this turned out to not even be that bad of a derivative to handle, right? They're just like single chain rules, which is fine, you know, like, and it's a chain rule we've done a bunch of, right? Like square root of a polynomial. That's one we should feel pretty good about doing. Same section?
Yeah.
Sure. Okay. Worth checking. Direct substitution. Sine of 0 is 0. And since sine is the numerator of tangent, I know that tan of 0 is also 0. So, seems like a good candidate. Let's L'Hopital. If I do a direct substitution again, cosine of 0 is 1. Secant is the reciprocal of cosine, so it's also 1, and 1 squared is just 1. So we're still indeterminate there. So I better do it again. But I like this because look what's going to happen this time when I do this. The 1s are out of there, right? So derivative of negative cosine is positive sine. How do I do the derivative of secant squared? It's a chain rule, right? So it's 2 secant x times the derivative of secant. What's the derivative of secant? Secant times tangent. No negative on this one. Yeah. Sorry. Yes. Because it was negative secant squared. I'm sorry, I thought you meant the derivative was negative. I'm like, no, that derivative is a positive. Yeah, I did drop the negative though. Okay, let's direct substitute now. So 0 over negative 2 times 1 times 1 times 0. So that's still indeterminate. All right. But we can make, what do we know about tangent? Let's think about trig identity time now, since we don't have any. It's sine over sine over cosine, right? What if I write it instead of sine over cosine? What if I write it as sine times secant? That be okay? Instead of writing it as sine over cosine, I do it as sine times secant. That's still okay? Can I do that? And now if I direct substitute, I'm done. What cosine? I wrote it as sine times secant. Is the 1 over cosine. So I just did it that way because it was, it wouldn't have mattered. You could have left it as sine over cosine, but it's easier to see why the sine was going to reduce if I wrote it that way. Could have you left it as sine over cosine and just reduced the sine still and left it as 1 over cosine? Sure. Why did I stop here and try to do some algebra? Yeah, so why here and not earlier? Because all I have here are trigs. There's no more addition or subtraction, just all multiplication. Hey, maybe there's something that can reduce here to make my life easier. That's what I thought when I saw this. And then I looked at the prospect of having negative 2 secant squared times tangent, having to do the derivative of that, which didn't seem very pleasant to me. Although I think if you did one more L'Hopital, it probably would have worked out for you to get the same thing. But I wasn't excited about trying to do that again. Of course. Yeah, go ahead.
Two or three questions that have the facts over this, but there's still some work.
It was probably because I started doing it and I realized that it was involving a skill that we hadn't done yet.
Oh, okay.
So I probably just crossed it off because I'm like, oh, nope, we got into something I didn't want it. Because I can filter the multiple choice questions from the AP to some extent, but some people don't do a good job of labeling the topics that are required for the question. And I just kind of glance at the question at first. I'm like, okay, yeah, this looks a little bit different of a presentation than the previous ones I've been looking at. Let's grab one of those, a couple of these. And sometimes I run into something, it's like, oh yeah, you're using integration to do this. I can't ask you to do this yet. The person that labeled this question did a poor job. So I just end up crossing it out or something. Because believe it or not, I don't do all 80 of them as I'm picking them. I pick them so I can get them to we and then I'll sit down and do them afterwards. So occasionally run into something that like just is inappropriate because we haven't got there yet. So anything that's crossed out, you can safely assume you don't need to worry about. What's next, guys? Folks? You can even be general then. Be general, that's okay. Yeah. No, I think I just did. I would say that if you had I would put a 3-9 multiple choice question if it didn't require a change of or elimination of variable. So like you remember reading when you did the 3-9 my AP questions, like the first 3, 4, 5 of them were just like you differentiated the equation, then you plugged the stuff in, and like you maybe had to do a little bit of light solving, but then you're done.
Yeah.
Like that kind of thing, I think is a fine FRQ question or a multiple choice question.
Okay.
If it required a bunch of stuff, like some change of elimination of variable stuff, that would I think is more appropriate as a free response question where I can see some more work being done.
Do you think there'd be like multiple FRQs like that?
No, I think one is enough.
I agree.
Yes, Beck.
Number 6 multiple choice.
Sure.
I know there's explanations.
Yeah, no, that's perfectly reasonable. Absolutely, we can do that. Okay, so it's the last question here that just anytime there. All right. Okay, it says let f be the function defined by f of x equals yada yada yada, and let g be a differentiable function whose derivative is given by yada yada yada. It is known that the limit as x approaches infinity of g of x is equal to 0. The value of the limit then of f of x over g of x is yada yada yada. Okay, so this to me screams L'Hopital, right? Because I know if I do the limit of f of x as x approaches infinity, I get infinity plus stuff that's infinity. And then the limit for g of x is infinity, right? So it's that indeterminate form of infinity over infinity. So let's L'Hopital that. So that's just going to be f prime of x over g prime of x, right? So from the problem, we're told what g prime is. It is 1 over x plus 4 cosine of 5 over x. And the derivative of f of x we can do because we have f given to us. That should be 2 minus 15 e to the negative 5x. Everybody agree with that? So now if I do a direct substitution here, I get 1/2. E to the negative infinity is 0 because it's like negative 15 over infinity, right? Is that? Yeah. Yeah. That felt okay?
Yeah. I think in the explanation, we just did the thing where you like push the limit up into the equation. I just couldn't remember what that was, so I wasn't sure about that.
Oh, okay. Yeah, sure. I was trying to do it without like too hand wavy, where I just write like, 2 minus 0, like I did here. I kind of talked.
Yeah.
Here I don't have the ability to talk when I'm writing it down. I mean, I do, but nobody can hear it. Yeah.
Why are you direct subbing this?
I didn't direct substitute in 0. I put in an infinity, but if I have an infinity in the denominator, it goes to 0, right?
What about that? Oh.
Is that okay?
Yeah.
So I did do infinities. I just wrote 0 because it was going into the denominator of a fraction. Pierce. On the multiple choice? Sure. Okay. So I'm just going to copy this part because all that is the same, right? Yeah. Okay. Now let's look at the specifics here. We know g prime is 4 plus 1 over x. And the derivative of f should be 3 minus 6e to the negative 3x. So if I direct substitute again here, I get 3 minus 0 over 4 plus 0. 3/4.
Your work that you did here, I think you know what you did again, but like your second step.
Let me look real quick then.
I'm confused on like up above. So see all the way to the right on that first line. Like there's X's now next to the 3 and -6.
Oh, sure.
I don't understand how that.
So I multiplied the top and bottom by x. I don't know why I felt like I needed to do that because I didn't. I should have just direct substituted right then and there and been done with it. But that's all I did was to clear the fraction here. And then L'Hopital again. I don't know why I decided to do that. I don't know. Sure, absolutely. Of course. 20, sure. I'm just going to grab the page, I think. It's enough writing for me. Okay. Okay. So the extreme value theorem, what is the hypothesis of it? What are the conditions that need to be met? Do you remember? Let's see.
Like the closed interval as
Continuous on the closed interval. So that's what I'm checking here right away, is I want to make sure that I'm continuous on from 0 to 2 pi. So if I look at number 1, sine can be -1 at 3 pi over 2, correct? So this one is out because I don't have continuity from 0 to 2 pi. Because it would give me a 0 denominator. Exactly, yes. If I look at the second one, that one should be okay because the denominator has always got to be a positive value. Okay, that's fine. If I look at this one, that one's out because we're undefined when x is pi because we get a 0 denominator. And same thing here. So the only one that meets the hypotheses for the extreme value theorem is B, because the other ones, I get a 0 denominator somewhere in that interval. Does that feel okay? And again, like, without remembering what the extreme value theorem is, what you need, the conditions, can't really do anything with it, right? Like, it's a straight up, do you know the extreme value theorem or not? Jacob.
Can you explain one more time why A was?
Yeah, so sine of 3 pi over 2 is -1. That would make a 0 denominator, which means that I don't have continuity from 0 to 2 pi because it's undefined at 3 pi over 2. And it's a little stinky because they gave you gave you trig stuff in here, so you had to remember, like, oh, what is sine of, where is sine equal to -1? And hopefully we remembered, like, okay, that's pointing straight down, 90, 90, 90.
But does that even matter if you know that at some point it does equal -1?
If you know on the yeah, it doesn't, because if you know from 0 to 2 pi, somewhere along there, that's the whole unit circle, sine is -1 sometime, that's enough to be like, I don't care when it happens. Sure, yeah, absolutely. The trick here would have been if it was like, -3/4 pi to +7/9 or something, like something terrible. It's like, oh my God, what are we doing? It's like, now I got to really look at what's covered.
Right.
And that's a lot harder. Still doable, but like, ugh, pain in the butt. I don't think they would do that to you on an AP exam. Isabel.
For number 25, are there only two things, like two CQIs, or 3. So I know I missed one on like our.
Which number? 25?
5. Yeah.
All right, let's take a look at what this is saying. Da-da-da-da-da. Okay. So I would start by just kind of like sketching in that secant line, right? So I would just be like, okay, well, it looks like I can draw one there and like one there, right? And there's nowhere else on there that looks like I can draw something parallel. It looks like just 2 to me. And the 2 are probably at R and U. Would be the 2 tangent lines there. Notice that if I try drawing a tangent line at T, that's clearly got a different slope. Oh, sorry. There would be 2 places, but I think if I draw the tangent line at R, R's at the minimum, right? So like let's draw them in different colors. So here's R. Here's T. And here's U. And then here's like W. So the one that we want is the blue one, right? That one looks like the parallel one. W, right? There's 4 letters down there. So that's all I'm doing. I'm just kind of like sketching in with a pencil real quick and seeing which one looks parallel. Does that feel okay?
Yeah.
So it's like real simple, but again, like the vocab is rough, right? Like you have to be like, okay, what secant? Okay, a secant line. So the answer was whatever the answer was for you. C.
It's just like a lot of words.
Yeah. Like again, I know that this is going to be a surprise. Math at some point really becomes a lesson in vocabulary. Like you really have to know the vocabulary, not just like know the definition, but have to like understand what the definition means in different contexts. You know, like really is one of those where it's like it's all about decoding what the question is asking for. Because usually, like it was in this case, it's like pretty simple when you see it being done, especially if there's like no calculation to do. It's a simple exercise in finding the right answer. But like decoding what is it that it's asking me to do to get to this right answer is not trivial, especially the first time you're really being asked to do math like this, where it's like this is a lot of conceptual vocabulary and like I really have to know and really have to understand the terms in a way that I've never really had to understand them before in math class. It's been so much symbol pushing to this point, and now the symbol pushing is like, okay, I can handle that part, but like the vocabulary and like the interpreting the question is becoming more of the challenge. And welcome to advanced mathematics, as that continues to be kind of the hard part, because at some point you go in here long enough and calculation disappears. Like nobody asks you to compute anything anymore. They're like prove this, if this thing is like this and that thing is like that, prove that this relationship exists between the two of them. And you're like, okay, so let me start unpacking this. And that becomes what your homework looks like, which is awesome, right? For example, let me grab